Identify the following key features of the graphs and then graph the function on the graph provided. Graph, graph, graph. So is it concave up or concave down is our first question. Well, we know that when a, which is the term in front of x squared, is positive, it's up, and if it's negative, it's down. Let's just write our function, just so we remember. So we know that because there's a positive 1 in front, we concave up. The axis of symmetry. The axis of symmetry requires we use the formula negative b over 2a. So again, here's ax squared plus bx plus c. So what is our b term? In this case, it is 3. So we have negative, for this guy, 3 over 2 times our a term is 1, which gives us negative 3 over 2, or you could write it as negative 1.5. So our axis of symmetry will therefore be x equals negative 1.5. And we will focus on graphing at the end. What is the vertex? So the vertex is going to require us to plug 1.5 back into the equation wherever we see an x. So it'll be negative 1.5 quantity squared plus 3 times negative 1.5 plus 2. I'm going to use my calculator for this. So 1.5 times 1.5 is 2.25. I didn't put negative because I knew a negative times a negative would be a positive. Plus, what's 3 times 1.5? Let's make that negative. We know it'll ultimately be negative, so 3 times 1.5 is 4.5, and then plus 2. So we are going to take 2.25, subtract 4.5, add 2, and we're going to get negative 0.25. Which is our y-coordinate. So therefore the vertex will be negative 1.5, negative 0.25. So let's go back and log that. All right, what is the y-intercept? Well, that one's easy. The y-intercept is always the c value. So our c is 2, therefore it's going to be 0, 2. And then what are the x-intercepts? So to do that, we're going to have to factor. Factoring allows us to find our x-intercepts. So we are going to first draw our box. And then we're going to put the ax squared term, so this goes here, and that goes down there, so x squared and 2. And then we want to figure out what multiplies to our ax squared times c terms. So this times this will just be 2x squared. And then also adds to our b term, bx, right, which is 3x. So we want to figure out what multiplies to 2x squared and adds to 3x. We know it's going to have x's in it, so I'll just go ahead and write those in right now. So we have to find the factors of 2, which are 1 and 2, which is easy enough. So it'll be 1x times 2x. 1 times 2 is 2. X times x is x squared. And then 1x plus 2x is 3x. So now we're going to factor out the greatest common factor from each column and each row. So from this column, we have two x's, a 2, and an x, so we can take out x, right? They have an x in common. From here, no variables in common, 1 and 2, while the only factor that's shared between them is 1. For here, we have 1x and then x and x, so we can take out an x. Here, we have 2x and 2, so we can take out a 2. Therefore, our factored form of the equation is x plus 1 and x plus 2. But to find the zeros, we have to set them equal to 0 and solve, which ultimately gives us -1, 0 and -2, 0. -1, 0, -2, 0. So now we're ready to graph. So I'm going to start with the x-intercepts. So -1, 0, -2, 0 is going to be a skinny guy. The y-intercept is at 0, 2. And then the x, or the vertex, is -1.5, so that's halfway between our x-intercepts, and then down a quarter of a value, right? So like right here. It's a little difficult to do. And the axis of symmetry will go right through that. I know that if this is the y-intercept, we want to make that symmetrical over the y-axis, so we'll put another one right here. So in essence, your parabola should have looked something like that.